Hey guys, I'm going to introduce lesson 21. This is writing and evaluating expressions. This is on multiplication and addition. So we've went over the ones on addition and subtraction, multiplication and division. So now we're on multiplication, multiplication, division. Now we're on multiplication and addition. All right, so let's look at the part that says classwork. All right, it says mathematical modeling exercise. The Italian Villa restaurant has square tables that the servers can push together to accommodate the customers. Only one chair fits along the side of the square table. All right, make a model for each situation to determine how many seats will fit around various rectangles. All right, look at the first chart. All right, you have one side that's number of square tables, and the other side that was number of seats at the table. All right, let's see. I know this isn't pretty. We'll make some rows here. Oops. All right, so it goes number 1, 2, 3, 4, 5, 50. I need 2 more here. 200, and then it says T. Let me fix this over here to make it kind of go to this side. All right, so if we had one table, look at the first box there to show one table. All right, it says that only one chair fits along the side of the square table. So how many sides do you see on the first one, the first box that's all by itself? Count them, and that'll be a number of seats, all the sides. There's 4. All right, all you have to do is count the sides for each square. All right, look at the second one where it was 2 tables pushed together. Okay, you have 2 on the top, 2 on the bottom, and then 1 on each side. So that's a total of 6 seats able to fit at that table. All right, look at the next one. It has 3 tables pushed together. All right, so you could fit 6 on the top. 3 at the top, 3 at the bottom, and then 1 on each side, which would be a total of 8 seats at the table. All right, the next one shows 4 tables pushed together. So that would be 4 seats at the top, 4 seats at the bottom, and 1 seat on each side. So that would total 10 seats for 4 tables pushed together. All right, and then the last one shows 5. All right, for 5 tables pushed together, you have 5 seats on top, 5 seats on bottom, and 1 seat for each side, and that would give you 12 seats. All right, and then it wants you to come up with 50. How many would be at 50, 200, and then it gives you the variable T. So go ahead and try to figure that out. See if you see the pattern of each one. What is the pattern to figure out the rest? I'm going to give you a couple seconds to try to figure that out. And remember, think about the title where it says multiplication and division when figuring it out, what the pattern is for this box. So you can figure out 50, 200, and see. Once you figure it out, it's really easy. Okay, so you should have seen that the pattern on this was you multiply by 2 and then add 2. So you multiply 2 and then add 2. So 50 times 2 is 100. And then 100 plus 2 equals 102. Because you have to remember the 1 on each side. Alright, so now let's try 200. 200 times 2. 200 times 2 equals 400. And then 400 plus 2 equals 402. Alright, and then it says t for the variable in the last one. So we give the expression for t for the number of seats. So it'd be 2t, because you multiply it by 2, plus 2. And that's it, because it's multiplied by 2 and then add 2. So go ahead and finish filling that in. Give you all just a second. All right, look at the first question. It says, are there any other ways to think about solutions to this problem? And really, regardless of the number of tables, there is always one chair on each end, and each table has 2 chairs. So look at the first one. On each end, there's 1 seat, and on each side, there's 1 seat. So I'm going to show you a little picture there to show you what I'm saying. Sorry, let me erase all this. Alright, so it's saying regardless of the number of tables, there's always 1 chair on each end. So there is a chair and there is a chair on each end, and then 1 on opposites of each other. So like if there's 1 table, there's going to be 4 chairs. If there's 2 tables, you're always going to have 1 on each end, alright, and then 1 opposite of each other. So there's 2 tables, there'll be 1, 2, 3, 4, 5, 6 chairs. There's 3 tables. There's 1, 2 on each end, and then 1 on each table, and then 1 opposite of each table. That'd be 1, 2, 3, 4, 5, 6, 7, 8 there. Alright, so the next one says, it is impractical to make a model of pushing 50 tables together to make a long rectangle. If we did have a rectangle that long, how many chairs would fit on the long side of the table? Well, it'd be, if you had 50, okay, well let's look at this one. The one with 2, there's 2 on each side. So if it was 50 tables pushed together, there'd be 50 on each side. So it'd be 50 over here, 50 on the bottom, and then 1 on each side. So that would equal 102. And if you look up at our chart where it says 50 tables, how many seats were there? There was 102. All right, the next one says, how many chairs fit on the end of the long table? Well, the end of the tables, each one, how many do you see on each table? Even for 1 table, there's 1 on each end. For 2 tables, these are the ends. There's 1, 2, 1, 2, 1, 2. Each one has 2 chairs on the end of each table. That's why you add 2 after you double it, because they have 1 on each at each table, and then 1 on each end. So that's why you double it and then add 2. All right, turn the page. It says how many chairs fit in all, round it to record it on your table. Okay, so if there was 50 like we already put, it'd be 102, because there'd be 50 on each side, there'd be 50 across from each other, and then 1 on each end, which would be 102. 50 plus 50 equals 100, and then 1 plus 1, you would add the 2, which would equal 102. All right. The next one says work with your group, and you're not working with a group, you're working by yourself to figure this out. Because remember, you are still in silence right now because of the behaviors, but you are to determine how many chairs would, work with your group to determine how many chairs would fit around a very long rectangle table if 200 square tables were pushed together. So remember what our expression is to figure out how many chairs is needed. It's 2t plus t, or plus 2. So if t equaled 200, you would say 2 times 200 plus 2 equals, well, let's see. First we do 2 times 200, following PEMDAS, and that'd be 400. And then we'd add our 2 plus 2, and that would equal 402 chairs. Alright, so the last one says if we let T represent the number of square tables that make one long rectangular table, what is the expression for the number of chairs that will fit around it? And remember, this is our expression here. That's all you need to write. That was on our last row. All right, if T stands for number of tables, you multiply T times 2, and then you add 2 for the ones on each end. There's always 2 ends to it. No matter how many tables you push together, there's going to be the left end and the right end. All right, there'll be 2 ends. All right, let's move on down to example 1. Example 1 says, look at example 1 with your group, which is by yourself now. Determine the cost for various numbers of pizzas, and also determine that expression that describes the cost of having P pizzas delivered. So P is our variable. All right, Pizza Queen has a special offer on lunch pizzas, $4 each. They charge $2 to deliver, regardless of how many pizzas are ordered. Determine a cost for various numbers of pizzas, and also determine the expression that describes the cost of having P pizzas delivered. So each one is 4. All right, so P, it'd be 4P, 4 times P, how many pizzas you have, plus your delivery charge, which would be 2. So go ahead and put that in. Where it says P at the bottom of that chart, this is what we're looking for by reading it. It's $4 each, so you multiply pizzas by 4. Each pizza is $4, so that's 4P plus $2 delivery fee. You add the $2. So put 4P plus 2 on the very last row, where it gives you the variable P for number of pizzas, and the total cost in dollars is 4P plus 2. And then I'm going to give you a second to try to figure out the rest of them using this variable. Look at number 1, 2, 3, 4, 10, and 50. You multiply it by 4, add 2, and you will fill that in. Alright, so we go ahead and look at the first ones. Alright, we'll go over this together. Alright, so this is the number of pizzas delivered. So I'm just going to put number of pizzas. And this one was total cost in dollars. Alright, and this says 1 pizza, 2, 3, 4, 10, 50, and then P. And for P, we already had that variable and what the expression is, which was 4P. We multiply pizzas times 4, what it costs, plus 2 for the delivery fee. All right, so let's do 1 times 4 is 4, plus 2 is 6. 2 times 4 equals 8, plus 2, our 2 here, equals 10. So that's our answer for 2. All right, 3 times 4 is 12, plus 2 is 14. And then we do 4 times 4 is 16. 16 plus 2 is 18. All right, then 10 times 4 is 40. 40 plus 2 is 42. Then it says 50 times 4 is 200, because you have 50, 100, 150, and then 200. So then 200 plus 2 is 202. So go ahead and fill this in if you have not already, or if you did not get some right. Okay, so let's go ahead and look underneath it. We'll ask you what operations did you need to perform to find the total cost. What do we use here? Well, there's multiplication. 4P means 4 times P, and then here's addition. So you use multiplication and division. You multiply the number of pizzas by $4, which was the cost, and then you added the $2 delivery fee. So for that one, you need to put multiplication and division. What did you multiply? What did you add? All right, flip to the next page. X out the part where it says, suppose our principal wanted to buy a pizza for everyone in our class, determine how much this would cost. We're not going over that because we're not getting our seats and counting everybody. Doesn't matter. I don't need it scribbled out or anything. Just put a small X right there. All right, and then look at B. It says, if Boosters Club had $400 spent on pizzas, what is the greatest number of pizzas they could order? And I want you guys to try to figure that out, to see how much they could order. If our expression is 4P plus 2, what number is the greatest they could order? All right, I'm going to let you guys answer that on your own. Also, look at C. It says if the pizza price was raised to $5 and the delivery price was raised to $3, create a table that shows the total cost, pizza plus delivery, of 1, 2, 3, and 4, and 5 pizzas. Include the expression that describes the new cost of pizzas, ordering pizzas. So I'm going to let you guys do 1 through 5, because your new variable now, it costs $5 per pizza. So 5P plus your delivery charge went up $1. Your cost of pizzas went up $1 to 5 instead of 4. And then your delivery cost went from $2 to $3. So you have 5P plus 3. All right, you go ahead and fill that in your last box as well. Where it says P for number of pizzas delivered, that is your variable. And where it says total cost in dollars, you have 5P plus 3. That is the expression used, and that's the expression you're going to use to fill in the rest of the boxes. So quickly write that down. All right, I'm going to go over the problem sets briefly with you guys. These are ones I'm wanting you guys to use what you have learned on these past few days with the filling in the boxes and using the variables to do that. So look at the problem sets. You have quite a bit. There's 1, 2, 3, 4, 5, 6 problem sets. You'll be filling these boxes by reading each question. All right, each question will give you, like for example, the first one says compact disc. which is CDs, cost $12 each at the Music Emporium. The company charges $4.50 for shipping and handling, regardless of how many compact discs are purchased. Create a table of values to show the relationship between the number of compact discs that Mickey buys, which is D, they use the variable D, and the amount of money he spends, which is C, in dollars. All right, so if they're $12 each plus a $4.50 delivery charge for each one, you would have, all right, so the CDs that he buys is D. All right, they're $12 each, so it's 12D is going to be expression used on that one. You just have to figure out, okay, how much do they cost? What is it? Plus, we're going to add our shipping and handling. How much is it for shipping and handling? It's just $4.50. It says no matter how many you buy. So even if you bought 10 CDs, you would just multiply 12 times 10 and then just add the one $4.50. All right, so like number 1, what's 1 times 12? That's 12. And then you just add $12 plus $4.50 for the delivery charge to get your total amount. 0 plus 0 is 0. 0 plus 5 is 5. Remember, when we're adding or subtracting decimals, we bring our decimals straight down. 4 plus 2 is 6. And then bring your 1 down. So your first one should be $16.50. So if you bought one CD, it'd be $16.50. So the next one says 2. So all you do is multiply 12 times 2 and just add $4.50 and do that for 3 as well. And then answer B and C below it. All right, number 2 will be the same. You've got to figure out what you have to multiply and what you're going to add. Most of these have something you multiply and what you add. Like this one, the books are $2.95 each. And the shipping is $4. So your shipping is more than what you're even going to buy for the books. So for the next one, you're going to fill out the chart by multiplying it by $2.95 times the amount of books you order, and then you're going to add the $4 shipping fee. So if you had, let's say that you had 3 books, you would say $2.95 times 3 plus the $4 shipping fee. All right, so if you look at the first one, I'm just going to show you the first one on that box. It says 1. So what's 1 times $2.95? So I put $2.95 times 1 plus 4. Well, 1 times anything, we've learned that already. 1 times anything is going to be that number. So that's going to be $2.95 plus 4. All right, 4 times $2.95 plus $4. Okay, 5 plus 0 is 5. 9 plus 0 is 0. Remember to bring our decimal straight down on addition and subtraction. And, whoops, sorry, I don't know why I put 9 plus 0 is 0. 9 plus 0 is 9. And then 4 plus 2 is 6. So $6.95 for that first one. So just remember that this is the expression used to figure out the answers for that one. So you're going to fill in the answers on the table and then complete the questions. All right, look at number 3 for the problem set. It says Sarah saved money to take a trip to Oregon. She receives $450 in graduation gifts and saves $120 per week working. Okay, let me erase this. So what would be our expression for that one? Well, first you need to put aside how much she earned for her graduation gift, which was $450. All right, and then you're going to add how much she makes per week. So you'll say 120W, because you're going to multiply that. Every week you multiply it by $120 and add that $450. All right, and so you'll finish filling in that chart, answer the question C. This is your expression. She already gave it to you for part A. And the last three is about the same. Make sure you I want you guys to be able to find out the expression used yourself. I cannot always give you the expressions. So you're going to have to read the problems, figure out what expression needs to be used, and do it. If you do not do it correctly, it's okay. You try your best, because when I go over it on the second video, that will be your time to change it. I hope that everyone works quietly and they work well. I do not want to see Mr. Holcraft having to get on to anyone else. Please do your best and try your best. I'll talk to you guys on the next video.